Hi, everyone. So far, the systems we've been solving have had one unique solution, expressed as an ordered pair or an ordered triple. But when does when does a system have no solution? When is the solution set the empty set? It's when you end up with a row that looks like this: 0, 0, 0, /1, for example. Basically, if we ever get a row of the form all zeros on the coefficient side, slash, and a non-zero constant on the right side. Now that happens, you have to stop, or you have the opportunity to stop, and you know right there, hey, the solution set is empty. Because here's the logic. If this system has a solution, then, among other things, 0 equals 1. Wait, this is like the idea of the contrapositive or indirect reasoning. Wait, 0 does not equal 1, so the system doesn't have a solution. 0 does not equal 1, so the system does not have a solution. So for example, let's solve this system. X plus y equals 1, x plus y equals 4. Well, for one thing, they correspond to a pair of parallel lines that aren't the same. But if you do it with matrices, if you try to apply GEBS, okay, here's the augmented matrix. Now, I know that I keep emphasizing addition, but here, let's go ahead and subtract row 1 from row 2. And we get what? 0, 0, /3. We keep row 1. Row 2 becomes 0, 0, /3, which would give us the equation 0 equals 3. Nope, the solution set is empty. By the way, I don't even bother putting this in row echelon form. You could divide by 3 to do that. Later on, we'll talk about row echelon form in more general settings. But you don't have to bother with row echelon form in the case where there's no solution, because you can't get our classic row echelon form. All right. Now, if you get all zeros, well, that's like 0 equals 0, which of course is a true statement. It depends on what's happening elsewhere. In this case here, we have the same stupid line, remember? Okay, and we have infinitely many solutions. Now, what if we have this augmented matrix here? Well, this guy ruins it. 0 equals 1. Because this equation here this yields the equation 0 equals 0. That guy's kind of chill, but this guy ruins it. In fact, you could have a matrix where you have all these all 0 rows, and then there's one guy that spoils it all, right? Like the weak link. If you see any row that's like that, it's empty set right off the bat. I don't care what happens anywhere else. Next up, let's define the row echelon form for a matrix, and I want you to know it when you see it. So basically, if I give you a matrix, can you recognize if it is in row echelon form or not? And also remember, when we did our GEBS problems, where there was one unique solution, we went to row echelon form. That's next time.